All right, guys. Today we are going to be talking about translating and word problems. All of this is in preparation for a Unit 3 test or for your Unit 3 retest as part of your remediation. So let's get started. First, let's look at this first question. It states, which of the verbal sentences represent the algebraic sentence below? So we have this algebraic sentence of -7 is less than or equal to 3x minus 4. Well, now we need to match what it says here to the words written in these four options. So I'm going to start out here. Right here, we should have the first part should be -7. And all of our options have -7, so I can't eliminate any of the options in A, B, C, or D. My second part right here is my inequality symbol. Well, that is a less than or equal to. So let's read each of these to see if we can eliminate any that don't have less than or equal to. So we have -7 is less than or equal to triple a number less 4. Okay, so that has it. -7 is less than triple a number. Well, that doesn't include the equal to, so I'm going to go ahead and eliminate option B. Let's look at C. We have -7 is less than or equal to 4 minus triple a number. Okay, so we can keep that one. And D says -7 is the same as triple a number less 3. Well, the same as is not less than or equal to, so we can eliminate D. So now we're going between option A and option C. Now let's look a little farther into the verb or into the algebraic sentence. This has 3 times a number minus 4. So let's see which one matches. This one states -7 is less than or equal to triple a number less 4. This one states -7 is less than or equal to 4 minus triple a number. Okay, well, if I was to write A, I would have -7 is less than or equal to triple a number. Now we could use 3 for triple a number, and then we could use less as subtract 4. So this one seems to have all of our pieces, but let's look and double check with C to make sure. -7 is less than or equal to 4 minus triple a number. Okay, so this one doesn't necessarily match, but A does. Because for C, it kind of has it flipped. These two pieces are flipped, so it cannot be C. All right, let's look at the second question. Which of the following is the algebraic form for the verbal statement shown? So let's read the verbal statement first. It says 8 more than the quotient of V and -5 results in 14. All right, so let's go through and we're going to pick out our pieces and write it in algebraic form. So we have 8 more than, and we can represent more than with a plus. The quotient, remember quotient means to divide. So let's look at the two pieces that we're going to be dividing. And we're going to be dividing the quotient of V and -5. So I can write that as a fraction, V over -5. Results in is going to give me an equal sign, 14. Okay, well, let me look back. Now, I see that this is an option, but let's read this one more time to make sure that we have it right. Well, there's something that I notice here. It says 8 more than. Now, remember, more than, they are reverse words. So we have more than or less than. That indicates that we are going to flip these two pieces here. Why can't I get back to just regular pens? There we go. Okay, so we're going to flip these two. So we would actually rewrite this as V. These are reverse because we have these reverse words, or they flip. plus 8 is equal to 14. All right, now let's make sure because this is looking at 8 more than the quotient of v and -5 results in 14. So we're adding that 8 onto the quotient of v and -5. So that's going to give us b. And that's how we use these reverse words. There's more than. So make sure you're looking for those. All right, let's look at this next question. Isaiah was asked to write the following verbal expression as an algebraic expression. So let's read the expression first and pull out our important pieces. 6 less than 4 times a number. Which expression is correct? Okay, so we have 6 less than, which we can write as subtraction, but just like in our last question, remember, less than is going to be something important for us. These are reverse words. All right, so let's pull out our last part, 4 times a number. So we can write 4 times a number as 4x. All right, now remember with less than, that means we reverse these two, we flip them, we put them in this one is now going to go first. So we would rewrite that as our second part first minus our 6. So that is going to give us a. Even though we used x, it's okay. Any variable can be represented by any letter. And looking back at this, when we say 6 less than 4 times a number, remember you are taking that 6 away from that 4x. That is why we reverse. So the answer would be A. All right, let's look at this word problem. It says Mary earns $12 every hour for babysitting Mrs. Brown's 2 kids, plus an additional $20 for cleaning the house while she babysits. If Mary earned $48 on Monday, find the equation which best represents the situation. So let's highlight the important pieces to the equation. So we have $12 every hour for babysitting Mrs. Brown's 2 kids, plus an additional $20 for cleaning the house while she babysits. If Mary earned $48 on Monday, find the equation which best represents the situation. All right, so let's start by writing our equal sign. And we're going to determine what's on either side of the equal sign. Well, on my right-hand side of the equal sign, we're always going to have our total. So I'm going to look here and determine which one of my numbers represents my total. So this one says 12 for every hour plus an additional $20, but she earned a total of $48 on Monday. So I'm going to write $48 as my total because that's how much Mary earned. All right, now we need to figure out what's on this side of the equation. Well, we have that she earned $12 for every hour plus an additional 20. So I have this plus here, and I'm going to represent $12 for every hour as 12x. I don't know how many hours she worked, but I know that every is a word that indicates multiplication, like each or per. So I can represent that as 12 times x for however many hours, plus this flat fee she got of $20 for cleaning the house. So our answer is going to be C. All right, let's look at this one here. Ayana bought 32 bottles of water. Each day she opens and drinks 3 of these bottles of water. Which inequality represents the greatest number of days she can continue before she has to replenish her stock? Okay, so I'm going to write this with a circle in the middle with my 2 sides of the inequality. Now, let's go back with our highlighter and let's pick out the pieces, or let's highlight the pieces of important information so we can fill this in. So she bought 32 bottles of water. Each day, she opens and drinks 3 of these bottles of water. Which inequality represents the greatest number of days she can continue before she has to replenish her stock? All right. Now, on my right-hand side, just like an equation, we are going to put our total. So the total number of bottles that Ayana has is 32. That's how many she purchased. Okay. Now it says that each day she opens and drinks 3 of these bottles. So like each or every or per or these words that indicate multiplication, that's each is indicating that each day, so she has 3 per day. So we can write that as 3D. Because if we inputted a number of days here, it would be 3 times that number of days to indicate how many bottles of water she drank. Now, our last step is to figure out what kind of sign that we're going to use here. Okay, well, we can kind of get some information based off of the question. It says, which inequality represents the greatest number of days? So the biggest. So we can write that with our sign going this way and an equal sign underneath. Now, the reason being is if we solve for this, when we solve for this, the number of days represented has to at least be the number of days that she would have to replenish that stock of water. But it could also be bigger. So it could also be bigger than that amount, and she would have to replenish it. So we are going to do 3D is greater than or equal to 32. All right. This one states create an inequality and solve using the practical problem given below. 2 families plan to go to the movies. The ticket for one adult was $11.84, and the ticket for one child was $6.77. There were 3 adults in the group. The families wished to spend no more than $65. What is the greatest number of child tickets that can be purchased? So we have to not only write an inequality, but we also need to solve. So I'm going to start here just with my 2 sides. And now I'm going to go back up into my problem, and I'm going to highlight the important numbers to this problem. So we have 2 families planned to go to the movies. The ticket for one adult was $11.84, and the ticket for one child was $6.77. There were 3 adults in the group. The families wished to spend no more than $65. What's the greatest number of child tickets that can be purchased? Okay, so let's start here with filling in what we think is going to go for our total. So it states that the families wish to spend no more than $65. So that's the total they want to spend. They want to spend no more than that. So I'm going to put $65 here on the right. All right, some of the other information that we have is there are going to be 3 adults that are definitely going, and it's going to cost them $11.84. So I'm going to put in 3 times $11.84 because I know that they are going to be, that we are going to spend this money. And then what we're also going to spend, we're going to add $6.77 per child. C. Okay, now I'm going to use Desmos. I'm going to help myself. I'm going to rewrite this. 3. I'm going to figure out how much we're going to spend on these adult tickets for sure. So we're certainly going to spend $35.52 plus our $6.77 per child. And we still need to figure out what's our symbol going to be. Well, it says that we want to spend no more than $65. And we can represent that as less than or equal to. So on this side, it should be no bigger than $65. All right, so to solve for how many kids we can bring, we have to solve our inequality. First, we're going to get our zero pair here by subtracting 35, 52 from both sides. And I apologize for my messy writing here, guys. I know it's tough. Well, this is 0, so I can cancel that out, and I can bring down my $6.77 C, because we're still trying to figure out how many kids we can bring. All right, let me use Desmos. We have 65 minus 35.52. Well, that gives me 29.48. Now to solve for C, I'm going to divide by 6.77 on both sides. So I can take my answer, 29 divided by 48, or 0.48, excuse me, divided by 6.77, and that gives me C is less than or equal to 4.35. Well, the question's asking me, what's the greatest number of kids tickets that can be purchased? Well, I know I can at least get 4 kids, but it says I could buy a little bit more, but I don't want to spend the rest to get that 5th child. So I know we can at least get 4 kiddos. And let me highlight that because it's kind of tough to see. But your answer will be B, 4 kids. So we can at least purchase 4. You could purchase 0.35 of a kid, but we don't buy 0.35 of a kid's ticket. So we can purchase 4. All right, last one, guys. So looking here, we have a scenario where Ricardo has a savings account. He started with $50 in his account. He deposits $10 into the account each week. What's the total amount Justin, and it should be Ricardo, excuse me, will have in his account after 12 weeks? Okay, so he already has $50 in his account. But we're going to be adding $10 each week for 12 weeks. So we could multiply that by the 10 to figure out how much he has. So he has his $50 in his account, $10 per week, and we were told that he gets that $10 for 12 weeks. So we can multiply these two together to figure out what he gets. So 50 plus 10 times 12. That gives us $170. All right, thank you guys. Have a great rest of your day.